Okay, here's a graph of the function f of x equals the definite integral from 0 to x of this expression right here. There's the graph. We're trying to find out where it's concave up, which means where the tangent lines are increasing in slope, which happens when the second derivative is positive. So we want to find y double prime and answer the question, when is the second derivative positive? Now, the fundamental theorem of calculus, part 1, implies that the derivative of this function right here is just 1 over 1 plus x squared, which I've rewritten as that quantity to the minus 1 power. If you're not sure about this, look up the fundamental theorem of calculus in your textbook and some problems on finding the derivative of a function that's defined that way. You'll see that if this upper limit is just an x, all you have to do is substitute it in for t, and you've got the derivative. Think about it. If you could find an antiderivative of this function, whatever it is, then substitute in x and minus 0 into that antiderivative, and then take the derivative, you'd be back to where you started. Okay, y double prime, power rule followed by the chain rule. It gives this form the opposite of 2x plus 1 all over 1 plus x squared, the quantity squared. When does this expression equal 0? When the numerator is negative 1/2. And so we want to test numbers on either side of negative 1/2 to find out what the sign of y double prime will be. Well, if you substitute in a number to the left of negative 1/2, like negative 2, the numerator becomes positive. The denominator is always positive. So to the left of negative 1/2 is where this function is concave upward. And negative 1/2 is actually the x-coordinate of the point of inflection because the concavity changes there. And depending on how you're specifying the where of this question, if you're using interval notation, you're probably going from negative infinity up to negative 1/2. Okay, there you go. Hope that helped.